Hello and welcome to the Chemistry Made Simple podcast. I'm your host, Matthew Macario, and this is the podcast where you get chemistry confident and we take you from point A to grade A. Hello, how are you? I hope you're well. You'll recall in the last episode, we talked about an introduction to alcohols and the alcohol group, and we defined them. And today we're going to talk about the reactions that alcohols go through. You may want to go back and listen to the last episode about the introduction to alcohols, because in that episode, we defined what we mean by a primary, secondary, and tertiary alcohol. And you will need to understand that for this episode. Very briefly, a primary alcohol is an alcohol where the OH group is on an end carbon. A secondary alcohol is an alcohol where the OH group is on a mid-chain carbon. And a tertiary alcohol is similar to a secondary alcohol, but that mid-chain carbon with the OH group has a side chain branching from that carbon as well. Okay, so the reaction types we're going to talk about today are dehydration or elimination and oxidation. So we'll start with the elimination, the dehydration reaction. Well, this is a reaction where we remove two hydrogens and an oxygen, effectively a water molecule, from an alcohol, and therefore we're going to turn that molecule into an alkene instead. The hydrogen lost is on the carbon adjacent to the carbon that has the OH group on it. So clearly there has to be at least two carbons in the alcohol. This cannot be done with methanol. How do we do this reaction? It's done in quite extreme conditions. We react the alcohol with hot, concentrated sulfuric acid, and we pass the vapours of the mixture across an aluminium oxide catalyst at 600 degrees. The product we get is an alkene and a water molecule. The next type of reaction we need to consider is oxidation reactions, and there are two kinds of oxidation reactions. The first one is the extreme example of combustion with oxygen, and if there's enough oxygen present, that will result in complete combustion and the products being carbon dioxide and water, similar to with an alkene or an alkane. There is a more gentle type of oxidation where we get quite specific products as well, and that's the one that we're going to focus on today. This is an oxidation we can do if we want to obtain an aldehyde or a ketone or a carboxylic acid as the product of our oxidation of an alcohol. Now, not all those products are available from each alcohol. We'll go into that. The reagent that we mix with the alcohol is potassium dichromate with dilute sulfuric acid. You might also hear that referred to acidified potassium dichromate. The reaction is usually done with some heating. We want to make the reaction go quicker, and potentially we might want to distill off one of the products as well, depending on which product we want from the reaction. So let's think about a primary alcohol first. A primary alcohol being one where the OH group is on an end carbon. When we carry out this oxidation reaction, we will get potentially two products. Initially, the first step of oxidation will cause an aldehyde to be produced. An aldehyde is an organic compound that has a double bond to an oxygen and a single bond to a hydrogen on the end carbon. So if we started with ethanol, we would get ethanal as the first product of oxidation. If we continue with the reaction and we don't take any precautions to remove the product, the oxidation will go a further step, and the aldehyde, the ethanal, will be turned into a carboxylic acid, ethanoic acid in this case. How do we choose to get an aldehyde, and how do we choose to get the carboxylic acid, depending on which product we want? Well, the aldehyde has a lower boiling point than the alcohol and the reagents in the rest of the reaction mixture. So we can set the reaction up initially to distill off the aldehyde as it's produced, and therefore we will collect the aldehyde away from the reaction mixture and no further oxidation will happen. If we set the apparatus up such that the mixture will reflux, then if there's enough reagent present, the reaction will go all the way through past the aldehyde and to the carboxylic acid. This is a key thing that you're almost certainly going to be asked about in your exam questions. Okay, how about a secondary alcohol? A secondary alcohol being one where the OH group is on a mid-chain carbon, and that mid-chain carbon also has a single bond to hydrogen. The same reaction mixture can be used with a secondary alcohol, again with heating, to produce a ketone. A ketone is an organic compound where a mid-chain carbon has a double bond to an oxygen and doesn't have any bonds directly to hydrogen atoms. So if we started with propan-2-ol, the product would be propanone. We don't need to be clever about distilling off the product. The reaction can't go any further with this reagent mixture. If you do this oxidation with a secondary alcohol, you will get the ketone related to the alcohol that you're starting with. And how about a tertiary alcohol? Well, a tertiary alcohol won't oxidize with this mixture. The carbon that the OH group is attached to is also single bonded to 3 more carbons. Those are very strong bonds, and this reaction won't break one of those bonds in order to allow a double bond from the carbon to an oxygen. Therefore, the oxidation can't proceed. Comparing the primary, secondary, and tertiary alcohols and what products you could potentially get using this reagent of acidified potassium dichromate is a common question that comes up in exams. Okay, so what have we talked about today? Well, we reintroduced primary, secondary, and tertiary alcohols. We talked briefly about the elimination reaction where we dehydrate an alcohol with at least 2 carbons, using hot concentrated sulfuric acid and an aluminium oxide catalyst and operating at about 600 Celsius. We also talked about combustion of alcohol and more specific oxidation of alcohols, primary, secondary, and tertiary alcohols. Primary alcohols giving us the possibility of an aldehyde or a carboxylic acid products, depending on how we set up the apparatus. Secondary alcohol giving us a ketone product, and tertiary alcohol not reacting with that reagent mixture at all, staying as an alcohol. Okay, I hope this has been a useful episode to you. As always, please head over to the podcast's Patreon community to ask any questions that you might have on this topic following this podcast. I'd like to say a big thank you to our latest patron, Jamie Lee Darmody. Thank you ever so much. And thank you to all the patrons out there who help make this possible, who are supporting the production costs for this show. Thank you. Thank you for listening to this episode. I hope you found it useful, and if you have had value from it, do consider visiting our Patreon community at patreon.com/chemistrymadesimple, where you'll be able to ask deeper questions about this topic and get more support for your studies too. So I look forward to speaking to you again in the next episode, and until then, do look after yourself, and goodbye.